So the first question here, what is the area of the plates of a 2 farad parallel plate capacitor? So capacitance is given. The separation between the plates is also given. D is also given. You know C is equal to epsilon naught into A by D. And so you find what cross multiply, get the value of A because all other values have been given here. So let's go to next sum. A capacitor of unknown capacitance is connected across a voltage of V volts. The charge stored in it is 360 microcoulomb. So jot it down like this. For a voltage of V volts, it is 360 microcoulomb. And then for a voltage of V minus 120, you're reducing the voltage and the charge stored is 120 into 10 to the power minus 6. You increase the voltage, what will be the charge stored? That's a question. I can read the question. Find the potential and the unknown capacitance. What will be the charge stored in the capacitor when it is increased by 120? So the three cases, you know Q is equal to C into V. So you do unknown capacitance C. So you just write Q1 is equal to C1 C into V. The capacitance is same, the voltage, initial voltage. And the second case, Q2 is equal to C into V, which is V minus 120. And then divide those two equations. You know the charges are 360 microcoulomb and 120 microcoulomb. So you'll get 3 cross multiplying this, you get the voltage to be 180. So in the first case is 180, then you're reducing by 120, so it gives you 60 volts, and increasing by 120 gives you 300 volts. Now that you know the voltage, you take this voltage and substitute it in the first equation, where CV is equal to 360 microcoulomb, and get the value of the capacitance. It will turn out to be 2 microfarad. Okay, so that was this question. Next question is the 38th question. A parallel plate capacitor has a plate of area 25 centimeter square, which is 25 into 10 to the power minus 4 meter square, and a separation is 2 millimeter, 2 into 10 to the power minus 3 meter between the plates is D. The capacitor is connected to a 12 volt battery. Find the charge on the capacitor. So you find the capacitance, and C is equal to epsilon naught into A by D. All values have been given. Substitute, get the value of capacitance, and you know Q is equal to C into V. They've asked for the charge on the capacitor. Just you know the voltage is 12 volts. It's given in the question that it is 12 volts. So just multiply and get the value of the charge. Now that's the first part of the question. The plate separation is decreased by 1 millimeter. What extra charge is given by the battery to the positive plate? See, this capacitor is still connected to 12 volts, and the plate's distance is decreased by 1 millimeter. Initially it was 2 millimeter, now it's 1 millimeter, so eventually the new distance is 1 millimeter. The capacitance will increase because epsilon naught into A by D dash. You find the new capacitance, obviously that's getting halved. You know the original capacitance, and it's going to be divided by 2. You get the new capacitance. Take that and find the new charge. Q dash is equal to C dash, new capacitance into voltage 12. You get the new charge, and you notice that the charge is also changed because the capacitance is halved. Obviously the charge will also get decreased, and basically it's also getting halved. But I had explained in the class that once you take a capacitor, and if you're going to increase or decrease the distance, the charge on the plate will never change. That's something that I have said, but I'm contradicting here. But there it was not connected to a voltage. When the capacitor is still connected to the voltage, and you are increasing or decreasing the distance between the plates, when you increase the distance, the capacitance will increase, and hence the charge will increase. When the distance between the capacitance is decreased, the capacitance will increase, the charge will increase. So that the value of the charge depends on the voltage, and when it's still connected to the voltage. But if I'm already taking a charged capacitor, fully charged capacitor, and I'm trying to move it apart or getting it closer, the charge would not change. That is a different concept. I hope you are clear with this point that I've said this. Okay, so let's go to next question. This is example 38 is over. Let's go to example 39. A capacitor of unknown capacitance is connected across a battery of V volts. A charge of 120 microcoulomb is stored in it. The charge has been given. So when the potential across the capacitor is reduced by 40 volts, the charge in the capacitor becomes 40 microcoulomb. It's just like previous sum. You have a V volt in which the charge is 120 microcoulomb. You can jot it down. When it was V volts, When it was V volts, the charge was 120 microcoulomb. Then when the potential of the capacitor is reduced by 40, so it's V minus 40, the charge on the capacitor becomes 40 microcoulomb. And now calculate the V and the unknown capacitance. What would have been the charge of the capacitor if it was increased by 40 is exactly the similar sum that we did before. You take this and you multiply this as you have the charge and you have the voltage, and you can write Q is equal to C into V to be the first equation, where the capacitance is same for all the cases. So it's 120 into 10 to the power minus 6 is equal to C into V volts. Take the second case and write it. It's 40 into 10 to the power minus 6 is equal to C into V minus 40. Just divide the first equation by second equation. It's 4 3s are 12 and C get cancelled. It's exactly like the last sum. 3V minus 120 is equal to V. 2V is equal to 120. So the unknown voltage is 60 volts. For the first case is 60 volts. For the second case it's 20 volts. For the next case is 100 volts. And taking this value and substituting in the first equation, you can find the unknown capacitance. So it's 120 into 10 to the power minus 6 is equal to C into 60, and as this is capacitance 6 2s are, so it's 2 microfarad is the unknown capacitance. And what is the charge in this case in V plus 120? You know the capacitance is 2 now, so you can find the charge in the third case, which is 2 into 10 to the power minus 6 into Q is equal to C into V. So you know the original voltage is we know it's 60, and so V plus 40 is 100 volts. So you can take this and substitute for the third case. It's 2 into 10 to the power minus 4 coulomb, or at 200 microcoulomb is the answer for this, and that's what this answer is. So let's continue with the next sum. This sum is example 39. The next sum is example 40. A sphere of radius 0.03 meters is suspended within a hollow. A sphere of radius 0.0 suspended within a hollow sphere of radius 0.05 meters. If the inner sphere is charged to a potential of 1500 volts and the outer sphere is earthed, find the capacitance and the charge on the inner sphere. Okay, this is about concentric spheres. You have this is an omitted portion. It's an omitted portion. We do not have it for CBSE boards, so you can just ignore this. Okay, and so you can ignore this sum. So let's go to 41st question. The thickness of the air layer between the two coatings of the spherical capacitor. Again, it's spherical capacitor. Spherical capacitor, one sphere, and the capacitance of that sphere is there, which is 4 pi epsilon naught into R. But there is nothing called a spherical capacitor, concentric spherical capacitor. We only in the portions have parallel plate capacitor and not concentric spherical capacitors with A's and B's as the radius, so ignore this. So let's go to next sum. A negative plate of a parallel plate capacitor is given a charge minus 20 into 10 to the power minus 8 coulomb. Find the charge appearing on the four surfaces of the capacitor plates. So this is the question. So here is a sum where they have given the plates 1, 2, 3, 4, and they are in the negative plate of parallel plate capacitor. A charge of minus 20 into 10 to the power minus 8 coulomb has been given. When a charge is given to one plate of the capacitor, it redistributes itself across all the four surfaces to ensure that the electric field inside a metal plate is 0. So let's consider this point P, just like how he has considered. He has written this is surface 1 and this is surface 2, and there's surface 3 and surface 4. He's taking this point P and he's going to consider the electric field here is going to be 0, because electric field inside a conductor you all know is 0. Okay, so he's taking like this, and so then he's we're going to find out how is the charge of minus 20 into 10 to the power minus 8 getting distributed across each and every surface. Okay, so for which, considering here this is the point P at which the electric field is 0. Okay, so let's consider that and this has been given a charge minus Q. Okay, this has been given a charge minus Q, and obviously the 2 and 3 are forming the parallel plate, which should have an equal and opposite charge. So can I say here there will be plus Q, and here again there will be a minus Q, and so in the last plate they have given it to be the total charge. This has got to be positive at this fourth plate, at this end it's got to be positive, and so you're writing, you have to write this as Q minus 20. The total charge is minus 20, is what was given, right? So it's so in such a way that the total charge is minus 20. So if you consider this as Q minus 20 into 10 to the power minus 6, you add all the charges, this charge and this charge and this charge, everything cancels out, the plus Q, you'll be left with minus 20 into 10 to the power minus 6. So you understand that. And so the fourth plate, let's consider this, in order for it to get a minus 20, it has to be Q minus 20 into 10 to the power minus 6. That should be the value of here. And so now let's locate the point P due to this minus Q. Okay, due to this minus Q in here, let me write it, due to this minus Q, it's going to be, the electric field is going to be terminating negative, and this obviously is a positive charge, and it's going to be emanating from positive. This is going to be positive. And let's look at the negative plate here. From here, this has got to be terminating in this, and this has got to be emanating from this positive surface. And so on solving all these electric fields, let's write these values of the electric field, which is sigma by 2 epsilon naught, and sigma is Q by A. So let's write the respective charges. So let's take this one, we're going to write it as negative minus Q minus 20 into 10 to the power minus 6. Let's ignore that for now, by sigma by 2 epsilon naught, or Q by A into 2 epsilon naught. Okay, so that completes the due to the positive plate, the right fourth plate. Let's talk about the third plate. Again, it's minus Q by A into 2 epsilon naught. Let's consider due to the second plate, it's plus Q by A into 2 epsilon naught. This and this get cancelled. Let's go to the first plate. First plate is again minus Q by A into 2 epsilon naught. And the net electric field at this point has to be 0. Therefore, this becomes equal to this. So it's minus Q by 2A into epsilon naught plus 20 into 2A into epsilon naught. And this is minus Q by 2A into epsilon naught is equal to 0. This and this gets added. It's minus 2Q by 2A into epsilon naught is equal to minus 20 by 2A into epsilon naught. So cancelling this and this, the negative and negative get cancelled, Q becomes equal to 10. Therefore, you literally understand that this has got to be minus 10 coulomb, this has got to be plus 10 coulomb, this has got to be again minus 10 coulomb, and this will be minus Q is the total charge. Q itself is 10, and so a 10 minus 20 is a minus 10. So a Q minus 20, which is a 10 minus 20, turns out to be a minus 10 microcoulomb. So if the question has got 10 to the power minus 8, not microcoulombs, it's got 10 to the power minus 8. So instead, everywhere you just have to take it into minus 8, and I hope you understood. So it is 10 into 10 to the power minus 8, and so depending on positive and negative, we anticipated this to be a positive charge, but eventually this became a negative charge, if you see. So then surface 1 has got minus 10 into 10 to the power minus 8 coulomb. The surface 2 is plus 10 into 10 to the power minus 8 coulomb. The surface 3 has got minus 10 into 10 to the power minus 8 coulomb. And the outer surface of the second plate, which is minus 10 into 10 to the power minus 8 coulomb. We anticipated this to be positive, but eventually that also turned out to be negative. This is the way it's getting redistributed. I hope you're clear. It's a very beautiful sum where you're taking some point within the plate to be 0, the electric field, and just based on that you're assuming it as minus q, and then therefore this is plus q and this is minus q, and therefore on the last end it has got to be q minus 20 into 10 to the power minus 6 in 10 to the power minus 8 in order to make it minus 20 into 10 to the power minus 8. Okay, so that's about this. If you don't understand, you can ask me in the class. So let's go to next question. The sum number was 42. Let's go to sum number 43. So sum number 43, two capacitors of capacitance 6 microfarad and 12 microfarad are connected in series. So a 6 microfarad and a 12 microfarad are connected in series and with the battery. The voltage across the 6 microfarad is 2 volts. Compute the voltage across the total battery's voltage. Two capacitors 6 microfarad and 12 microfarad connected in series. You know the charge that flows through here will be the charge that flows through here, and you know that Q is equal to C into V, 6 into 10 to the power minus 6 into 2, which is 12 microcoulomb is what is going to flow through here. Once you know this charge 12 microcoulomb, you can find out the voltage. V is equal to Q by C. So 12 into 10 to the power minus 6 by 12 into 10 to the power minus 6. So you know 1 volt, and therefore the total voltage should have to be 3 volts. That is going to be appearing across both together. So let's go to the next question. Two capacitors of 3 microfarad and 6 microfarad are charged to a potential of 2 volts, and so in this sum you have a 3 microfarad and also a 6 microfarad. They are connected to 2 volts and 5 volts respectively. These two charged capacitors connected in series. Find the potential across each of the two capacitors. Which means if these two capacitors are already charged to 2 volts and 5 volts. Initially it's charged to a potential of 2 volts. It was charged to a potential of 5 volts, and now we are sharing it in series though. Okay, so you know what is the potential now across the two capacitors. You know that what was the original charge. You know this is the 3 microfarad is the capacitance and 6 microfarad is this capacitance. What was the original charge when it was already charged to 2 volts and 6 volts? Q1 is equal to 3 into 10 to the power minus 6 into 2 volts, which is 6 into 10 to the power minus 6 or 6 microcoulomb. And the charge which was across the second capacitor is CV again, 6 into 10 to the power minus 6 into 5, which makes it 30 into 10 to the power minus 6, 30 microcoulomb. The two capacitors came with already charged to 6 microcoulomb and 30 microcoulomb. When you're going to do sharing of the two capacitors, the net charge is Q is equal to Q1 plus Q2, therefore it's 36 microcoulomb. And so you know the total charge now, and you can find the net potential. V is equal to Q by C. Since the capacitors are connected in series, it is 3 into 6 by 3 plus 6. Okay, 6 3s are 18 by 9. So the equivalent capacitance is 2 volts and C equivalent, so 36 by 2. So 18 volts is the net voltage after it's been connected. Individually, if you want to see, you know this is the total, this is in series, and 36 microcoulomb flows through here. 36 microcoulomb flows through here, and you want to find V is equal to Q by C individually. 36 into 10 to the power minus 6 by 3 will make it 12 volts microcoulomb here, micro, so it's 12 volts across this. And across this again you can do the same thing. you get 6 volts. Okay, so this was 18 volts total, so you get 12 volts here. You can subtract and write 6 volts there. It is up to you. So that's a beautiful question. Let's go to the next question. Two capacitors having capacitors 5 microfarad when connected in parallel, 1.2 microfarad when connected in series. Okay, when two capacitors having capacitance of 5 microfarad when connected in parallel and 1.2 microfarad when connected in series, calculate their capacitances. Oh, so which means they've given a combination. Two capacitors are connected in parallel. The equivalent capacitance, can I take it as 5 microfarad, and they are connected in series. The equivalent capacitance is 1.2 microfarad. Can I assume like that? And so they're asking for the individual capacitances. Are they two identical capacitors? That's not been given. I wish the question was much more clear. Yeah, that's right. So they've given equivalent capacitance. So when they're connected in parallel, you're going to consider this is C1 and C2, and this is C1 and C2. Okay, so this is in parallel. In parallel, C1 plus C2 is equal to 5 microfarad. And this is in series, which is C1 C2 by C1 plus C2 itself is given to be 1.2 microfarad. And C1 plus C2, this itself can come here and be substituted. C1 into C2 is equal to and therefore you can substitute here 5 microfarad and it's 1.2 microfarad. So you can multiply these two, and C1 into C2 therefore is 6. 12 5 is 60, so it's 6 into 10 to the power, the micro will make it 10 to the power minus 12. So you get 6 into C1 into C2. So you can therefore now solve it like a linear equation. You can write a C2 in terms of C1, 6 into 10 to the power minus 12 by C1, and substitute that in this linear equation. C1 plus C2 is equal to 5 microfarad, of course. C1 plus C2 is 6 into 10 to the power minus 12 by C1 is equal to 5 into 10 to the power minus 6. So you get a quadratic equation. So when you take LCM, C1 square plus 6 into 10 to the power minus 12 is equal to 5 into 10 to the power minus 6 into C1. So it's C1 square minus 5 into 10 to the power minus 6 C1 plus 6 into 10 to the power minus 12 is equal to 0. So my only case is C1 plus C2 is a 5 microfarad, and this is 1.2 microfarad. So when I multiply micro 10 to the power minus 12, it's correct. So you have to solve this linear equation and just calculate what is your C1. So when you solve this, you can write this as 3 2s are 6. So C1 square minus 3 into 10 to the power minus 6 minus 2 into 10 to the power minus 6, and the product of which will get you 10 to the power minus 12 with a C1, and 6 into 10 to the power minus 12 is equal to 0. Therefore you get C1 to be 3, and the capacitance was 2 microfarad and 3 microfarad. Okay, so it's C1 into C1 minus 3 into 10 to the power minus 6 minus 2 into 10 to the power minus 6 into C1 minus 3 into 10 to the power minus 6. So C is either 2 microfarad, C1 is 2 microfarad, or it's 3 microfarad. So if C1 is 2, C2 will be 3. If C2 is 3, C1 will be 2, and vice versa. So thus you are able to find the unknown, the different combinations equivalent is given. You can find the unknown capacitances. So that completes sum number 45. Sum number 46, 3 capacitors of equal capacitances when connected in series have a net capacitance of C1. 3 capacitors of equal capacitance connected in series has a capacitance equivalent C1. When they connected in parallel, that is C2. What is C1 by C2? You know this is series. So if you 3 capacitors equal capacitance, they're all C, C, C. This is also C, C, C. So in the first case is 1 by C plus 1 by C plus 1 by C, which is 3 by C, or You have reciprocal C by 3 is equal to C1. In the next case, 3C is equal to C2. You know, C by 3 is equal to C1. C is equal to 3C1 and C is equal to C2 by 3. So the ratios of, what are they asking? They are asking what is the ratio of C1 by C2. You can keep it like this only and divide C1 by C2. C1 by C2 is C by 3 by 3C. C and C get cancelled, it's 1 by 9. So that's about that question. So let's go to next question. So 47th question. Calculate the charge supplied by the battery in the following arrangement. Calculate the charge supplied by the battery in the following arrangement. If you see that the C1 and C2 are in parallel, you can see that it's parallel by way of the charge getting split up. Can you see from here the way the charge is getting split up? You know, C1 and C2 are parallel. So you can just draw this, rearrange and draw this. This is C1 and C2, and both of which are just connected to a battery of 10 volts. You can just redraw it like this, then it becomes easy. 5 microfarad and this is 6 microfarad, and so the equivalent is 11 microfarad. And you know the voltage is 10 volts has been given, and you can find the charge Q is equal to C into V, C equivalent into V, which is 11 into 10 to the power minus 6 into 10, which is 110 microcoulomb is the charge which is flowing through and is going to get split up between the two capacitors. Are they asking for calculate the charge supplied by the battery, the total charge only they're asking. They didn't ask you for individual. Even if they did, it's very easy. You know that they're parallel, so this will also get a 10 volt, this will also get a 10 volts. You can just get the charge on this Q is equal to C into V, 5 into 10 to the power minus 6 into 10. So it's 50 into 10 to the power minus 6. This will be 60 into 10 to the power minus 6. It's pretty direct. Okay, so I hope you are clear. Let's go to next question. This is sum number 47. Let's go to sum number 48. So I couldn't locate sum number 48, so I'm redrawing the whole question. I've done that here. The 10 microfarad, 5 microfarad, 5 microfarad are capacitance connected to a 6 volt battery with positive and negative. Let's do this sum separately. I can't locate the picture. You can see that's sum number 48. Okay, what are they asking? Find the charges on each capacitor. Okay, we know that this is the main capacitor, and these are just getting split up. So the total charge will flow through here. Let's find the equivalent capacitance. This and this are definitely in parallel, so it's 10, and this 10 microfarad is going to be in series with this 10, and so it will become 5 microfarad. C equivalent is 5, and the charge Q is equal to C into V is 5 into 10 to the power minus 6 into 665. So 30 microcoulomb is the total charge which flows through here, and it's going to get split up equally because it's equal capacitors. So we can say it's 15 microcoulomb and 15 microcoulomb is what's going to appear here. We can do it like that, or we can say that this has got a parallel connection. Okay, that's all. It's 15 microcoulomb. So is that they're asking find the charges on the 3 capacitors. Yes, we found every charge. Okay, that's this question. So let's go to next question. Is the 49th question. That again is not there, so I'd like to write it here and finish it off. Obtain the equivalent capacitance of the network. For a 300 volt supply, determine the charge and the voltage across each capacitor. Okay, the capacitor diagram is given like this. This is C1, which is given to be 100 picofarad. Then there is a 200 picofarad here, and there is a 200 picofarad here, and there is a battery or a voltage here which is 300 volts with a positive and a negative, and I have one more capacitor here which is 100 picofarad. Okay, so we have to find the equivalent capacitance of the network and determine the charge and the voltage across each capacitors. So I know these two are in series, so it is 100 picofarad is the equivalent of this row. There again it's 100 picofarad, and but here this is like a main voltage, entire charge, main capacitor, the entire charge flows here and then gets split up. Okay, so then let's calculate the equivalent capacitance. This is 100, this is 100, and both of these together are parallel, which is in series with this 100 picofarad, correct? So then therefore it's 100 and 100 which is parallel, which is making it 50 picofarad. So these two together, this is 100 picofarad, this is 100 picofarad, and those two together or in parallel, parallel means it's 200 picofarad. That is in series with this 100, so it is 200 into 100 by a 200 plus 100, which is 20000 by a 300. So it's 200 by 3 picofarad is the C equivalent, and I know the voltage is 300 volts, and the net charge is C equivalent into voltage, which is 300. 200 by 3 into, of course there's a picofarad, into 300, which will be 20000 picofarad, or 20000 into 10 to the power minus 12 farad. So this is 2 into 10 to the power, give a 4 there, it will become 10 to the power minus 8 farad. That will be the charge. 2 into 10 to the power, that's a charge that's flowing through the main capacitor, the total charge, Q total. And let's see how it's going to split up. It's going to split up equally, because here again is 100 and here again is 100. And they are in parallel, the voltages are also equal. So you can just say it is going to split up equally. So 1 into 10 to the power minus 8. 1 into 10 to the power minus 8 coulomb flows here. Another 1 into 10 to the power minus 8 coulomb flows there. That's all. It's very simple. So those are the two questions which I was not able to cover because I couldn't locate the photograph. So then there is a 52nd question is there. Where is the 50th question? Again, the 50th question is missing, but this is the 50th question. This is the 50th question. Can you see the network has been given here? Find the equivalent capacitance of the combination of capacitors between the point A and B. Okay, between the point A and B. You have to find the equivalent capacitance. Also calculate the total charge that flows in the circuit when a 100 volt battery is connected between A and B. Okay, we'll find the total charge. First, let's find the equivalent capacitance. These three are in series. These two are in parallel. So parallel means these two are just 20, and those three are 1 by 60 plus 1 by 60 plus 1 by 60, which is 3 by 60. So it's 1 by 20. 20 microfarad is this, and this again is another 20 microfarad. And these two are in parallel, so which makes it 10 microfarad. Parallel means you have to add, so it's 40 microfarad. They're parallel, so it's 20 plus 20 is 40 microfarad. That 40 microfarad is in series with this 40 microfarad. Series means it's 40 into 40 by 40 plus 40, which will make 20 microfarad. So you got the equivalent capacitance of 20 microfarad. Without even really writing, you're able to circle it and find out. Okay, the 20 microfarad. Now the whole thing is getting connected to a voltage of 100 volts. So you can find the total charge. Q is equal to C equivalent into V, which is 20 into 10 to the power minus 6 into 100, which will make it 2000 microcoulomb. That's the total charge which flows through, and that is going to flow through the main capacitor, because this is separate, and you have the 2000 microcoulomb flowing through here, which is going to get split up as, you already know this is 20 and this is 20. So can I just say that's going to split up equally? Can I just say that the 1000 microcoulomb flows through here and another 1000 microcoulomb flows through there? But that will be like these are in series. So all the three capacitors is going to get 1000 microcoulomb, and you can find the voltage across every capacitor. Therefore, it's V is equal to Q by C. What is the charge? 1000 microcoulomb 10 to the power minus 6 by what is the capacitance? 60 into 10 to the power minus 6. So it's 100 by 6 voltage. There is 100 by 6 here. There will be obviously 100 by 6 and 100 by 6, or 50 by 3 volts is what is going to appear across every capacitor in here which are connected in series. Were they asking for the potential, or calculate the total charge that flows through? That's all. The total charge is the question. So we have already found the total charge to be they've said the total charge to be 2000 microcoulomb. I already got it, or 2 millicoulomb. We already got this answer. The question is not about finding individual charges, so you don't have to worry, but if they ask you, you know how to do it. I've just proceeded also. So let's go to the next question, which is the 51st question. The capacitors are connected like this. Calculate the equivalent capacitance of the network. You know that these three, as soon as you see, are connected in series. A C1, C2 and a C1, and this is 3 picofarad, C2 is 2 picofarad, and a C1 is again 3 picofarad. They're connected in series, so it's 1 by 3 plus 1 by 2 plus 1 by 3, all with the pico of course, into 2 into 3 into 2 will make it 2 plus 3, 5, 5 plus 2, 7 by 6, and I have to reciprocal, I get 6 by 7. And that is going to be in parallel with C2, and C2 is again 2 picofarad. It's going to be parallel, I can just add it, so it will be sort of 14, 20 by 7 till here, and that is going to be in series with C1 and C1 again, and C1 is nothing but a 3 picofarad and a 3 picofarad. It's going to be in series, so 1 by 3 plus 1 by 3 plus 1 by did I reciprocal it and add it with 20? Yeah, so 120 here and a 7 here, and so I can find the equivalent capacitance using this. That was sum number 51. Yeah, so it is 7 by 20, 1 by 3. This answer is 61 by 60 picofarad, and that's the C equivalent, and that's the question. So let's go to next question. So 52nd, let me spot the 52nd question and then come back to you. The 52nd, again I don't see the question properly. I'll tell you what is the 52nd question. The 52nd question's diagram is this, and I will read out the question for you from the network shown in this figure. No, that is not the diagram is like this. Okay, I'll just redraw the diagram for the 52nd question. You have a capacitor C like this, and which gets into another capacitor like this. It's quite a complicated circuit. I didn't do this in the class, that's the reason I've not taken a picture as well, but let me do each and every sum here. I'm not missing, I don't want to miss out on anything. So you have a C1, and you have a capacitor like this, and you have another capacitor like this, and a capacitor like this, and the circuit comes like this, and this is your B, and they've given this is the point A, and this is C, this is C1 which has got 8, and this is C2 which says 2, there is C3 which says 2, and there is a C7 which says 1, C5 which says 6, and a C4 which says 12, and a C6 which says 4. So then from the network, find the value of the capacitance C if the equivalent capacitance between the point A and B is 1 microfarad. So there is a capacitance C whose capacitance is unknown. All other capacitances are given, and equivalent capacitance is given to be 1 microfarad. It's a C equivalent of the circuit. So you have to find the unknown capacitor. Let's continue with the sum. You know that C2 and C3 are definitely in parallel, and that's going to become a 4 microfarad capacitor. Similarly, you have a C4 and a C5 which are definitely in series. So it's 1 by 6 plus 1 by 12. The LCM is 12 into 2, so it's 3 by 12 or 1 by 4. So 4. This itself is again 4 microfarad. And then that 4 microfarad is going to be in parallel with this 4. You can see that it's going to be in parallel with this 4. Yeah, so we can say that put together is going to become an 8 microfarad, and this already is a 4 microfarad. What you have here is a 1 microfarad capacitor, but what you have here is a 8 microfarad. Okay, let's now redraw the circuit. You don't know this unknown C, but you know this is 8 microfarad, which is in series with a 4 microfarad. And the circuit goes like this. There's a 1 microfarad here, which in turn goes and connects to an 8 microfarad in series, and then comes back and joins like this. And so you can see that they're all in series. They're all in series. Or no, they're not in series. These two are in series, these two are in series. So if I take, because there is a split up here, can you see? Can you see here? Getting split and coming together as one. That shows that these two are in series, which is 8 and 1, which is of course 8 into 1 by an 8 plus 1, which is 8 by 9. So that's the series, and these two are again series, which is 8 into 4 by 8 plus 4, which is 12. 8 4s are 32 by 12. And what would this become? 32 by 12 is can cancel 16 by 6, or an 8 by 3. This is 8 by 3 and this is 8 by 9, and those two are in parallel, so I can just add them. Let me see if I'm getting the answer. Into 3, so it's 24 plus 8. What would this be? That would be 32 by 9, and that's the equivalent, which is connected to C in series. So if it's in series, can I write 1 by 32 by 9 plus 1 by C, or which is equal to, the equivalent capacitance is 1 microfarad, which is 1 by 1 into 10 to the power minus 6, or I can do C1 C2, C into 32 by 9 by C plus 32 by 9 is equal to 1 microfarad, C equivalent. With this, will I be able to get that answer? C by C plus 32 by 9 is equal to, I can push this down and reciprocate 9 by 32, and so now I can just cross multiply. And do you think I can get the answer for this? I should get it as 32 by 23. I get the answer as 32 by 23. Let's see if I'm getting it. So can I now reciprocate 3 plus 32 by 9 by C is equal to 32 by 9. So now I can split this as 1 plus 32 by 9 by C, or 9C is equal to 32 by 9. 32 by 9C is equal to 32 by 9 minus 1, and 9 is the LCM. 32 minus 9 is nothing but 23. And so 32 by 9C is equal to 23 by 9. 9 and 9 get cancelled. 23C is equal to 32. C is equal to 32 by 23. And I got the answer, and that is microfarad, and such a beautiful sum. So when such complicated sums you come across also, you should be able to redraw the circuit and finish it. That's about sum number 52. Let me deal with sum number 53. Obviously that will also not be there, so let's go to sum number 53. Hope it's recording. Yeah. Connect 3 capacitors, 3 microfarad, 3 microfarad and 6 microfarad, such that the equivalent capacitance is 5 microfarad. So they are asking you to connect a 3 microfarad, a 3 microfarad and a 6 microfarad in such a way that C equivalent is 5 microfarad. So you have to try the combinations, right? You will try to connect them all in parallel, and when you add a 3 plus 3 is 6, 12. It's not equal, it is 5. So it's definitely not in parallel. Imagine all of them are in series is 1 by 3 plus 1 by 3 plus 1 by 3, 1 by 6. Well, 6 is LCM into 2 into 2. So it's 2 plus 2 plus 1, which will make it a 5 by 6, which is 6 by 5, which is not this again. So therefore the only possibility is either 3 and 6 are connected in parallel, so the 2 are overruled. So you are only coming across this where you're thinking maybe 3 and 6 are in, 3 and 3 are in parallel, 6 is in series, 3 and 3 is in parallel, it is 6 microfarad, and with 6 microfarad in series will make it 3 microfarad, that is also overruled. So definitely we are left with 3 and 6 in parallel, and series with the 3. Let's try this. It's parallel means it's 9, and a series is 6. It's 9 into 6 by 9 plus 6. 9 6 are 54, 9 plus 6 is 15, That again is not getting you an answer. So next is other combination is a 3 and a 6 in series in parallel with a 3 microfarad. This is another combination. So series is always 3 into 6 by 3 plus 6, which is 6 3s are 18 by 9 it's 2 with a 3. So then answer is beautiful, and this is the right solution. So juggle it around and get your answer. So that completes the 53rd question. So let's go to 54th question. 54th question, let me see if it's there. Oh, this whole sum didn't get recorded. The 54th question, I hope it's recording now. Yeah, 7 capacitors, each of capacitance 2 microfarad, are connected in such a configuration so that the effective C equivalent is 10 by 11. So you're going to assume that you're connecting n in parallel, 7 minus n in series, and so n in parallel, each of 2 microfarad will become 2n microfarad is the C equivalent in parallel, and you have 7 minus n connected in series, so 1 by C plus 1 by C plus 1 by C. So you have to reciprocal this. This is C equivalent in series, and both of them together are in series, so you just write it like this, and reciprocal the 10 by 11 because these are reciprocals, and then cross multiply, get a quadratic equation, and you get n have to be connected in parallel, so 2 have to be connected in, n is equal to 5 are connected in parallel and 2 are connected in series. You get an answer like this. So let's go to next question. So I'm going to deal with 56th question. So let me deal with the 55th question. And as you can see, find the equivalent capacitance between the point P and Q. Given that C is equal to 18 microfarad, C is given to be 18 microfarad, and C1 is given to be 12 microfarad. Okay, so you have to find the equivalent between P and Q. You start coming from the right corner. So you see that these two are in series, and C itself is 18, and they are in series, 18 into 18 by 18 plus 18. Yeah, and that is going to be in parallel with this C, which is again 18. So parallel, so plus 18, so you get this 27 microfarad sort. That is going to be in series. That's going to be in series with, so you get a 27, that's going to be in series with this C, which is 18. So that 27 into 18 by 18 plus 27, and that answer is going to be in parallel with this, and so then they're adding with a 12, and that's what goes in here. Okay, so you solve till here. That answer that you get is 23 microfarad, and that again is going to be in series with the C, which is 18. So it's going to be in series with 18, and then parallel with again with this 18, so plus 18, and you get 28 till here, and that is now in series with the C and is in parallel with this. So you just keep on doing that and you get the answer. I hope you understood. So let's go to next question. Is the 56th question. So you have a 56th question. The 4 capacitors are connected in such a way. Calculate the equivalent capacitance between the point X and Y. Okay, the moment you see that this is a plain wire which connects between this and this and this and this, you notice that these points are at the same potential. These points are at the same potential. So from point A, it goes to 2 microfarad, and similarly from the point A it goes to 3 microfarad, and from the point A it also goes to another 3 microfarad capacitor. So you know that this is 2 microfarad, this is 3 microfarad, and this is the 5 microfarad capacitor. So like that, you understand that they are all in parallel. So when you come from the right side, let me come from the right side, you have a separate 10 microfarad here, which in turn is connected with this capacitor and with these capacitors, and so then they go like this and go like this and go like this. So all the 3 are in parallel, and it's in series with this 10 microfarad. All the 3 of them are in parallel. All of them are at the same potential. The points are at the same potential. So the point, this is also point A, this will also become point A, this will also become Yeah, so then therefore you end up drawing like this, and these three are in parallel, so just add 2 plus 3, 5, 5 plus 5, 10, and 10 and 10 are in series, so it's 5 microfarad is the equivalent capacitance. As soon as you see this, you can say the answer. So let's go to next sum, and this is similar to a Wheatstone's bridge. I've taught you Wheatstone's bridge, where I'll just recap that in the next lesson. When I teach you, I'll draw resistors like diamond shaped resistor with a galvanometer which acts as another resistor across, and if this resistor P by Q ratio is equal to R by S, then there will be no current flowing through this galvanometer, making this P and R in series and Q and S in series. So this is similar to that. If you see that this C3 is where this galvanometer is in this position, and you know this is C1, this is C1, and this is C4, the C1 and C4, and this is C2 and this is C5. Okay, so then when they both are proportional, they're all of capacitance C. 5 capacitors, all of 10 microfarad, so it's 10 by 10. So we can say C4 by, you know that these two are C4 and C5 are in series, and C1 and C2 are in C1 and C4, which was originally in parallel. C1 and C4. So this is C1 and this is C4, and this is C3 and this is C5. The C1 and C4, which were originally in parallel, because of the galvanometer or the capacitor here, since there's no charge flowing through, these two become series, these two become series, these two become series, and those two eventually become parallel. This answer and this answer becomes parallel. So that's what it is. So if you understood that C1 and C4, so it is C3, this is C2, this is C1, this is C3, this is C4, and this is C5, and the center one is C3. Okay, so you know that therefore C1 by C1, and this is C2, right? This is C2. The bottom one is C2. C1 by C2 is equal to C4 by C5, because no charge flows through C3. This is the ratio, and therefore you know that C1 and C4 are going to be in series, C2 and C5 are going to be in series. I hope you're clear. So I'll redraw this for you for better clarity. Just see this. You know that originally the C1 was here and the C4 was here. They were parallel because of the C3. And the C2 was here, and there is a C2 was here, and there is a C5 which was here. And can you see, because of C3, the C1 and C4 were originally in parallel, but no charge will flow through C3. Why? Because C1 by C2 is equal to C4 by C5, which makes sure that these two are in series, these two are in series. So then it is 10 microfarad and 10 microfarad series makes it 5 microfarad. This is another 5, and 5 and 5 are parallel, so it's 10 microfarad is the equivalent capacitance. They ask you to find that. I hope you're clear. This is comparable with Wheatstone's bridge, which you'll learn next lesson. That is the 57th question. So let's go to 57th question is over. Let's go to 58th question. The 58th question is here. As you can see, how would you connect an 8, 12 and 24 microfarad capacitor to obtain maximum capacitance? You know that the maximum capacitance is only when you connect them in parallel, and minimum capacitance is when you connect it in series. That's what they are saying. Okay, if the potential difference of 100 volt is applied across the system, what would be the charge on the capacitors in each case? You know the equivalent capacitance, Q is equal to C into V. That's all. So for parallel, you have individual, the voltages is same in parallel, but the capacitance is C1, C2, C3. So just calculate the individual charges. So let's go to next. This is infinite capacitance. It's like a ladder sum. The ladder keeps on going. Can you see that? It's a 1 microfarad and a 2 microfarad. A 1 microfarad, 2 microfarad, 1 microfarad, 2 microfarad. You just take it till infinity and take this as C. You know the equivalence of the entire capacitance is also C, even though you left this 1 microfarad and 2 microfarad. You take the rest of it is also C. So you know that C is in series with this 2. So 2 into C by 2 plus C is the equivalent, and that's going to be in parallel with this 1. Plus 1 is equal to equivalent capacitance C. So 2C plus 2 plus C by a 2 plus C is equal to C. Just solve it and you get the answer. And so it's 3C plus 2 is equal to 2C plus C square. So you get a quadratic equation for this, and you solve it, you get C square minus C minus 2 is equal to 0. So you get C is equal to 2 microfarad or minus 1 microfarad, and not possible for it to be negative, and so therefore C is equal to 2 microfarad. This is for infinite capacitance. So let's go to next sum, which is the 60th question. Let me search for the 60th question. 60th question is here. You can see that they have earthed this, which means the potential here is 0. Okay, given C1 is equal to 20 microfarad, C2 is equal to 30 microfarad, and C3 is equal to 15 microfarad. They are all connected in series, and the insulating plate C1 be at a potential of 90 volts, one end, and C3 is earthed. Earth means potential is 0. What is the potential difference between the plates of the capacitor C2? Just the potential difference across the saloon. You find the total charge. You know the equivalent capacitance is 1 by 20 plus 1 by 30 plus 1 by 15. Reciprocal it, you get C equivalent to be 20 by 3. You can find the total charge. Q is equal to C equivalent into V. You get 600 microcoulomb. That's the charge that flows through here, and so you know that's the same charge that's going to flow through the middle one also. And you know the charge, you know the capacitance, and V is equal to Q by C. Just substitute and you get the potential across that. That's question. Let's go to next question. In a circuit of 2.82, if again this is getting earthed, can you see that this is the potential 0 and this is at a potential 1200 volts. Find the charge on each capacitor and the potential at the point B. The potential at this point. If you find the charge that is flowing through this, if you find the charge that is flowing through this main capacitor, you can multiply, you can do V is equal to Q by C, and hence find the potential that's absorbed by this capacitor. So you can subtract it from 1200 and then get the potential at B. So for which you have to find the equivalent capacitance, where you know C2 and C3 are in parallel. So 6 and 6 is in series with 3. So 6 into 3 by 6 plus 3. So you know it's 6 into 3 by 6 plus 3, which is 18 by 9. So 2 microfarad is the equivalent capacitance. You know that potential charge is Q is equal to C into V. C equivalent 2 into 10 to the power minus 6 into voltage is 1200. So it's 2400 microcoulomb is the total charge, and that's the charge which is going to flow through the main capacitor. And once I do that, now I'm just thinking, can I find the potential across this saloon? And V is equal to Q by C. Q is 2400 into 10 to the power minus 6 by a capacitance 3 into 10 to the power minus 6 getting cancelled. This is 800 volts. That's the potential across there. And so then this is going to take 800 volts to be the potential to acquire so much charge. 1200 minus 800. Therefore, at this point, it will be 400 volts. Will be the potential on the point B. Then that gives you the potential at the point B. That's a question. We've answered it. And find the charge on each capacitor. So we have already found this charge to be 2400 microcoulomb. It's getting split up as across these two capacitors, and okay, you know that this has taken away 800 volts across this capacitor is 800 volts. The total capacitor voltage is 1200 volts, and so the balance voltage left across for this parallel connection is 400 volts, and here again there's a 400 volt. So you can individually calculate the charge through these capacitors. Q is equal to C into V. It's 4 into 10 to the power minus 6 into 400, which is 1600 microcoulomb. is the charge that flows through on the let me check if this is correct. Yeah, that's correct. And similarly, you go for this this charge here. That's, you can call it as Q2. You can call this as Q3. Is again the capacitance 2 into 10 to the power minus 6 into the voltage will remain the same, 400. So it's 800 microcoulomb. So that's the way you can find the sum. And let's go to the next question, which is the 62nd question. A network of 4 10 ohm resistors is connected to a 500 volt battery. Determine the equivalent capacitance of the network. You know that these three are definitely in series. So if you know the values of the capacitance, each of 10 microfarad, the series, so you can just do this and reciprocate 10 by 3 microfarad, and that's going to be in parallel with this. So plus 10, which gives you this C equivalent, and determine the equivalent capacitance and find the charge on each capacitor. You know that this is 500, so this is 500 volts, and you immediately know what is the capacitance is 10 microfarad, and you can find Q is equal to C into V, which is 10 into 10 to the power minus 6 into 500 volts, which will directly give me 5000 microcoulomb to be the charge that's going to flow through here. 5000 microcoulomb is what's going to flow through here. Let me find the total charge. You know, C equivalent is the C equivalent into V, and which is 13.3 into 10 to the power minus 6 into voltage is 500. You multiply this, you get the total charge to be, what is it, 5 3s are 15, 5 3s are 15, 16, 5 1s are 5, 66.5 into 10 to the power minus 6, and this is the total charge. You can subtract it, 66.5, no, and 66, 6650 into microcoulomb. That's right. And so then if you're going to take away 5000 microcoulomb from that, the balance is what is going to flow through the balance, the other circuit. I hope you understood. So this is so easy, no? This one, if you know this is 500 volts, you can immediately find the charge that's flowing through here. Find the total charge and subtract it to find the charge that's flowing through the balance of the circuit. So the sum is over. 60-second sum over. Let's go to 63rd question. Let me spot the sum. Here is the 63rd question. Determine the potential difference between A and B. Now, if you know the charge that flows through here and here, and if you know the capacitances, okay, let's see. Okay, they have not given the values in the sum. So you know C1 and C2 are in series. So it's C1 C2 by C1 plus C2. And you know C3 and C4 are in series. C3 C4 by C3 plus C4. And they both are together in parallel. And so then equivalent capacitance C1 C2 by C1 plus C2 plus C3 C4 by C3 plus C4 is the C equivalent into voltage V will give me the total charge that's going to flow through the entire. Yeah. Okay, so that gives you the total charge. But we don't need the total charge here because you know this has got a voltage V. This has got a voltage V, and you know that a C equivalent for that row is here, and you can multiply it with V to get the charge through the second row, and charge through the first row. You know this is C equivalent, and this has also got the voltage V. So thus you know that the same, this Q1 is going to flow through here. You know that that's the charge, and you find the voltage across V1. V is equal to Q1 by C, C1 C2 by C1 plus C2. V is equal to Q by C, which is C1. C1 get cancelled. I got the voltage across V1. Let me get the voltage across V2, which is Q2 by C3. So C3 C4 by C3 plus C4 is the voltage across this, is the charge across this, by the capacitance is C3 get cancelled. Thus I got these voltages, and I want, this is potential at A, this is the potential at B, and they want VA minus VB. Just take this and subtract it, and thus you should get the answer. So then thus you should get the answer to be what is it? It's the potential C2 by C1 plus C2 minus C4 by C3 plus C4, take LCM and write the answer C1 plus C2 into C3 plus C4. So it's C2 C3 plus C2 C4 minus C1 C4 minus C2 C4. That will be the potential difference between, and in this something is getting cancelled, C2 C4 is getting cancelled. That's about it. So when will the potential between this and this be 0? VA minus VB have to be 0. Then you know that the numerator has to be 0. C2 C3 has to be equal to C1 C4, and that's a special condition that they are dealing with. And therefore you know that a C1 by C2 will be equal to C3 by C4. In that case you can write it like this and leave it like that. So let's go to sum number 64. Sum number 64, I'll search for the sum. So sum number 64 is here. 5 identical capacitors, each area A, are arranged adjacent plates. Okay, you can read the question for yourself. It's an IIT question. Can you see that plate 1, plate 3 and plate 5 are connected to positive terminal, and the plate 2 and the plate 4 are connected to negative terminal? And can you see that because of this is completely positive, and this is red color, this is completely negative, this is completely positive, and this is completely negative, alternating, and this is completely positive, which means a positive and negative makes it one capacitor, negative and a positive makes it another capacitor, but they are in parallel because negative and negative are connected. You understand? Negative and negative are connected. So I have to redraw this. Okay, it's a very, very important sum where when I redraw it, I know that the plate 1 is here, which has received a positive potential. The plate 2 is here because it is being shared with both 1 and 3. This is plate 1, this is plate 3, this is plate 2, there's a plate 4 and a plate 5. So you understand how, because the 2 is getting shared with 1 and 3 and a 4 is getting shared with 3 and 5, I have to do it accordingly. And so then in a parallel plate, this is the parallel plate. Okay, so then that's a parallel plate capacitor. Okay, so coming back to this, these are all at a positive potential. These are all at a positive potential, and these two are at a negative potential, and goes on like this. And the question is, 5 identical capacitors, each of area A, are arranged such that adjacent plates are at a distance d apart. Okay, separation is d. Calculate, the plates are connected to a source of voltage V. Find the charges on various plates, the charge on individual plates. Okay, you know that this is a positive plate. They are talking about the charges on individual plate. Okay, so you know that this this is a positive plate, and they're asking about the charge on every plate. You know the Q is equal to C into V. The charge on that plate, and C itself is epsilon naught into A by D for any parallel plate capacitor into voltage V, and that will be the charge which will be positive on the plate 1. On the plate 1, it will be epsilon naught into A by D into B. On the plate 2, since this is a negative charge plate, you know the first one is positive charge, so I wrote the charge to be positive. The second was a negative charge plate, so I'll write minus epsilon naught into A by D into V. That will be the charge on plate 2. But the plate 2 is also shared with plate 3. There will be again another charge due to plate 3, which will also be epsilon naught into A by D into V, which together will make it minus 2 into epsilon naught into A by D into V. That will be twice for plate 2. So let's go to plate 3. Plate 3 will have a positive charge, and it is getting shared with 2 and 4, so double times. So then again Q, the charge, it will be positive 2 into epsilon naught into A by D into V will be the charge on Q3. So let's go to Q4. Q4 is a negative plate, so, and that's getting charged with 3 and 5, so minus 2 into epsilon naught into A by D into V, again it's twice. Whereas the plate 4, the plate 5, if you see plate 5, it's getting charged, paired only with 4. So there's no sharing, so then therefore it's, and it's a positive, so epsilon naught into A by D into V with a positive charge will be the plate charge on plate 5. So this is such a beautiful question. So I hope you all understood. Let's go to 65th question. So the 65th question is a very important question. If you see, the question says steady state. Find the potential difference between the point A and B. A is here, B is here. At a steady state, the word steady state means equilibrium. Steady state means equilibrium. Equilibrium means the capacitors are fully charged and no more charges will flow. No more charges will flow. So then these two resistors can be ignored because there's no current. When you charge your mobile, once it's fully charged, it blocks DC. No more DC current flows through. So the resistors, there's no potential drop across this resistor. So you can ignore the resistors in a steady state because no current will flow through. I is equal to 0. So let's find the equivalent capacitance of this network. You see that these two are in parallel, which makes it 6. These two are in parallel, which makes it 2 microfarad. And this is 6 microfarad. And those two are in series. So 6 into 2 by 6 plus 2, which is 12 by 8, which is 4 by 3 microfarad is a C equivalent. And those two are in, with this 1 microfarad, they are going to be in parallel. That's something you need to realize. That's going to be in parallel with the 1 microfarad. So it's 4 by 3 plus 1. So when you do 4 by 3 plus 1, you get the equivalent capacitance. Are they asking about 4 by 3 plus 1, which is 7 by 3 is the C equivalent? And are they asking about equivalent capacitance? No, they didn't ask for the equivalent capacitance. They're asking for potential difference. Once I know the C equivalent, I can find the total. The charge anyway is 0. Okay, so then find the potential difference between A and B. You know, so then this can be reconstructed as 6 microfarad capacitor, and this can be reconstructed as 2 microfarad capacitor, which is in parallel with the 1 microfarad capacitor, which is connected in turn to a 100 volt battery. That's all. The resistors are all invalid because steady state, no current or no charge flows through. So then they are asking potential difference between A and B. You know, that's mere wire only, so this point A can also be written here. Therefore, if you know the charge acquired by this capacitor, now I know it would have acquired a charge, right? I know no more charges are flowing through, but it would have acquired a charge. If you know that charge that this capacitor would have acquired, then it becomes easier. Let's acquire charge, not flowing charge. Please understand that this is going to be 100 volt. Let's find the charge through here. Q is equal to charge acquired is C into V, 1 into 10 to the power minus 6 into 100. So 10 to the power minus 4 coulomb is the charge that flows through here. And this whole thing is again 100 volt. And you know the C equivalent for this row alone is a 4 by 3 microfarad. And that 4 into 10 to the power minus 6 into 100 will give me 4 by 3 into 10 to the power minus 4. And that's a charge that's acquired by this. You know the charge acquired by this is so much, and you can find the voltage. Therefore V is equal to Q by C, which is 4 by 3 into 10 to the power minus 4, is it? By C is 6 into 10 to the power minus 6, and this becomes 4 by 18 into 10 to the power 2, and this is 2 by 9 into 10 to the power 2, or 200 by 9 volts is the potential difference between the point A and B. Let me check if my answer is correct. 1 second. This is the 65th sum. Potential difference across the 6 microfarad No, my answer seems to be wrong. I'm getting 100 by 3. Let me see what is a mistake, okay? So I have a 6 microfarad, 2 microfarad and 1 microfarad. I'm trying to find the potential difference across 1 microfarad is equal to the potential difference between the top points. So I wrote it as 100. I know that the equivalent capacitance of this is 6 into 2 by 6 plus 2, which is 12 by 8, which is maybe this is wrong. I wrote this wrongly as 6 by 4 or a 3 by 2. That's 3 by 2, and this has to be 3 by 2. So when this is 3 by 2, sorry about the calculation mistake, and this is 3 by 2 into 10 to the power minus 4. So once you know that is the charge flowing through 3 by 2 into 10 to the power minus 4, you're dividing it by 6. This is 1 by 4 into 10 to the power 2, 100 by 4, which is 25 volts. I hope you're clear. I made a calculation mistake there. So that's about 25 volts, and that's a potential. You should always imagine a steady state. Then how do you find the charge? It's an acquired charge. It's fully charged capacitors. Okay, I hope you're clear. That completes the 65th question. So let's go to 66th question. Let me search for that question. 66th. Let me go up and see. 66. An air-filled parallel plate capacitor with the separation 1 millimeter has a capacitance of 20 microfarad. Okay, it's then it is charged to 4 microcoulomb. Okay, so an air-filled capacitor with separation 1 millimeter, capacitance 20 picofarad. It is charged to 4 microcoulomb. Calculate the amount of work done to pull the plates to 5 millimeter. You're pulling the plates apart, assuming the charges on the plates remain the same. This is what I was telling. Here they are not talking about any voltage. So when there is no voltage, it's an already charged capacitor, and you're moving the plates apart, it will not affect your charge. Be very clear, it will not affect your charge. The charge will remain the same. Even here it's 4 microcoulomb only. Only the capacitance will change. In the capacitance of the original capacitor is epsilon naught into A by D, which is here it is 5 times. C dash is epsilon naught into A by D dash, because area of the plate is never going to change. Area is going to remain the same. So it's C by C dash. C by C dash is equal to D dash by D, which is it's 5 by 1 millimeter, doesn't even matter. So you know that therefore the original capacitance is 20 microfarad. This is 20, and 5 fours are 20, and C dash is equal to 4 picofarad. So that's about this question. Remember this, that when it's not connected to the voltage and you're moving it apart, it will not affect the charge, only the capacitance will change. So that completes the sum number 66. So sum number 65, 66. What is the sum? Sum number 66. Okay. So 1 second. So let's go to sum number 67. Where is 67? Let me go up and see where is 67. Yeah, I have 69. Shit, I don't have it. Then I'll do sum number 67, where the photograph I have not taken. 2 identical capacitors of 12 picofarad. Each of them are connected in series. Okay, so you have a 12 picofarad capacitor and another 12 picofarad capacitor. They both are connected in series, and they are connected to a 50 volt battery. Okay, so how much electrostatic energy is stored in the combination? If these were connected in parallel, so we are going to again connect them in parallel, and we have to compare their electrostatic energy. I think how much energy will be stored in the combination. Also find the charge drawn by the battery in each case. So in this is series, so it's C1 C2 by C1 plus C2, which is 6 picofarad. It's a C equivalent in this case. In this case it's 24 picofarad, and so you know that the potential energy is just half CV square. So you find the for the series you put in half C equivalent 6 into 10 to the power minus 12 into V square is 50 the whole square. You calculate this energy, 75 into 10 to the power minus 10 joules is what you will get for this. And let's talk about the charge in this. Q is equal to C equivalent into V, and this is 6 into 10 to the power minus 6 into 50, so it is 3 into 10 to the power minus 10 coulomb is the charge here. Let's take this case. This is C equivalent in parallel, and the energy stored in this parallel connection is half CV square. C equivalent is 24 into 10 to the power minus 6 into voltage is again 50 the whole square. Therefore, you get the energy to be 3 into 10 to the power minus 8 joules. So you understand that when it is connected in parallel, it stores much more greater energy because 10 to the power minus 10. So parallel stores better energies, better charges also. Let's see the charge across parallel is C equivalent, which is 24 into 10 to the power minus 12 into voltage, which is 50, will give you 1.2 into 10 to the power minus 9 coulomb. So this power is lesser, that shows that the charge is greater. So that's that question. Let's go to next question. Next question is the 68th question, where a 12 picofarad capacitor is connected to a 50 volt battery. So a 12 picofarad capacitor is connected to a 60 volt battery. How much is the electrostatic energy stored in? It's just half CV square. So you get 1.5 10 to the power minus 8 joules. Okay. So if another capacitor of 6 picofarad is connected in series with it, you're taking this 12 picofarad and connecting it with another 6 picofarad capacitor in series with it. Once again, hold on. It's going to be connected in series with it, with the same battery, so the same 60 volts connection. Find the charge stored and the potential difference across each capacitor. How much is the electrostatic energy in the previous one? You just have to do half CV square, which is half into, what is C? 12 into 10 to the power minus 12 into 60 the whole square, whose value is 1.5 into 10 to the power minus 8 joules. And now the moment you connect in series is 12 into 6 by 12 plus 6, which is 12 6 is 72 by 18, which is 4 picofarad is the equivalent. And you want to find the charge, this is 60 volts. Q is equal to C equivalent, which is 4 into 10 to the power minus 12 into V, which is 60, 240 into 10 to the power minus 12, or you can say 2 into, 240, 4 equivalent, 60 is the voltage, you're finding the charge, Q is equal to C into V. Oh, this is 50 volts, is it? It's 50 volts, sorry. 50 the whole square, just check your notebook, it's 50. So thus you get this to be 2 into 10 to the power minus 10 coulomb. Then they're asking for find the charge stored and the potential difference across each capacitor. You know that the charge that's going to series, and you know 2 into 10 to the power minus 10 close to in series, you can find the potential here. B is equal to Q by C, and then again here also B is equal to this Q by C, and you can get the individual potentials V1 and V2, that's all. So let's go to next sum. This is example 69. Example 69 is here. Find the equivalent capacitance of this. Okay, in this, this is quite, can you see the same wire which connects this and this, and so these points are the same potential, P and S are the same potential. So we can say that the P and S are the same potential, which is in turn connected to C2, which is in turn connected to C3, which is in turn connected to a C4 also. But the thing is, there is a point A from which there is a C1, and there's a point B from which there is a C5, but the C5 from the right end is connected again to C4 and also connected to C3 and C2. So this is the way you complete it, and these three are in parallel and all of them are in series, and then thus you can complete the sum. Okay, so that's about this. 69th question, I'm sure you understood. Let's go to sum number 70. So sum number 70 is here. Three identical capacitors C1, C2, C3 are of 6 microfarad, each are connected to 12 volt battery. You can say that the C1 and C2 are definitely connected in series, and that's going to be connected in parallel with C3. So each of 6 microfarad, series means it's 3 microfarad, and that is going to be in parallel with the 6 microfarad. So equivalent is C equivalent is 9 microfarad. You found that the C equivalent becomes a 9 microfarad. Then what are they asking? The charge on each capacitor, energy Equivalent capacitance of the network. Yeah, that's done. Charge on each capacitor, you know that this is C3, which is a 6 microfarad capacitor, and the voltage across this is 12 volts. So you can do Q is equal to you want a Q is equal to C into V and just multiply and get the charge across through capacitance C3. And then you know that the equivalent capacitance of this C1 and C2 is 3, and you know the potential is still 12 volts here also, so because they are parallel, and so immediately you can find the charge through C1 and C2. So that completes the charge through C1 and C2. The energy stored in the network is half into C equivalent into V square. So if you know C equivalent, which you have found out, 9 microfarad into V square, you can just get the answer. I hope you're clear. So let's go to the next question. It's the 71st question. The 3 capacitors are in parallel, so find the equivalent capacitance, and this is in series. So 2 plus 3 is 5, 5 plus 6 is 11. 11 and the 1 microfarad are in series, so you find the equivalent. So what are they asking in this? The energy is stored in C4. Oh, they've given the energy stored in C4 alone is 27 joules. Okay, so you know that the energy stored in that, which is half into 6 into 10 to the power minus 6 into, you should know the voltage for here, you don't know, which is V square is equal to 27. So can I do that? Yeah, with which you can find what is V, that's what they have done. So they got the voltage to be 3 into 10 to the power 3. V square is 9 into 10 to the power 6. So once you get the voltage, you can find the energy stored in C2, which is half into 2 into 10 to the power minus 6 into that voltage that you calculated. You can plug in that same voltage, which is 3 into 10 to the power 3 the whole square, and you can get the energy stored in that capacitor, and the energy stored in the system, is it? So thus you found the energy stored in now. This is sum number 71. You found the voltage, then you found the you find the energy stored like this in 2, 3 and 4 individually. Okay, that this total energy stored in 2, 3 and 4 will account to 49.5 joules on plugging in the same voltage of 3 into 10 to the power 3 whole square, V square, in the place of V square, and plugging in the respective capacitances, you get the total voltage. You have to add all the energy, you have to add all the energy, get 49.5, and the energy stored in the series, and you know that how to find the energy stored in this capacitor unless you know the you can find the charge. You know that the energy is 49.5 is the energy stored here. You can use the formula half Q square by C equivalent to be equal to 49.5. I'm sorry, let me write half into Q square by C equivalent for this section alone to be equal to 49.5, and hence you can find the charge that is flowing through here. Once you find the charge, that will be the same charge which flows through C1, and hence you can find the potential by multiplying V is equal to Q by C. Get this potential and substitute half C1 V square, half C1 V1 square. Amazing sum, amazing sum. And please go through what they have done in Arora. You will understand. It's very self-explanatory. Beautiful sum. Okay, because I was for a minute struggling with this, how to find the charge through. You find the charge through the other wing using the energy, using the formula half Q square by C, and you're done. And so let's go to 72nd sum. Let me spot the 72nd question. Next is the 72nd question. You can see this is the network. They have simply connected a wire like this, which means they have shorted the circuit. Shorting a circuit means they are taking it away from the circuit. connecting these two are the same potential, and that there's no charge that's going to flow through. They're shorting it, so they are left only with the C3. Here we don't see, the previous sum had like this a wire which goes from here to here, so we know that the charge is connected here also, is connected like this also. This is unlike that sum, this is different. Okay, so we did a sum where it was like this, where you had a mere wire which goes through from here to here, and so you know that this wire connects to this capacitor, also to these two capacitors. This is not a sum like that. You know that here this wire connects to this capacitor also across these two, but you are not, this is different from this. Okay, in what way is it different? Okay, let me draw this. In this you have three capacitors like this, where they take a wire and connect it like this from the point A, and then they take another capacitor here with, and you know that there will be like this, and they ask you to find the equivalent capacitance between A and B. That was different, but this is different. This is not anything similar to this. This, can you see the fact that this is getting connected like this and this is getting connected like this? You see that they are all interconnected. They're all interconnected, unlike in this where this two can be taken off. So you just have only a capacitance C3. I hope you're clear. And so then therefore equivalent capacitance is 2 microfarad, which is just of the capacitance C3. The maximum energy supplied, maximum charge supplied by the battery, you know the Q is equal to C equivalent into V, and then half CV square for finding the potential. Very, very important sum, beautiful sum. Okay, let's go to 73rd question. 800 microfarad capacitor is charged by a 100 volt battery. After some time the battery is disconnected. So basically it is acquired a pre-existing charge 810 to the power minus 9 farad, minus 12 picofarad, and it's being charged to a potential of 100 volts. And after some time you're disconnecting. After some time the battery is disconnected. The capacitor is then taken and connected to another 800 identical capacitor. Okay, it's connected to another identical capacitor. So you know that what can you say? It has already had a charge Q. Now it's connected in series, or how is it connected? It's connected to another 800 picofarad capacitor. Does it mean that it's connected in series or parallel? You know, whenever you connect like that, a charged capacitor with an uncharged capacitor, you know the common potential formula is C1 V1. So which means you need not have connected it in series. Let's the concept that we studied is we had connected it like this with the positive and a positive, and so we denoted C1 V1 plus C2 V2 by C1 plus C2 being the V common potential. The charges will flow until they attain a common potential. So you calculate this, you know the respective, you know once voltage is 0 because V2 is 0, V1 is 100 and C1, so the capacitance is given 800 picofarad. So that's capacitance C, sorry. So then you have C1 which is 800 into 10 to the power minus 12 into the voltage which is 100 volts plus and a 0 by C1 plus C2 is 1600 into 10 to the power minus 12. So, yeah, so it is 0, 0 will get cancelled. This whole thing is becoming 0. This is becoming 1 by 2, 100 by 2, 50. So V common is 50 voltage. So once you get 50 volts, you can then find what is the electrostatic energy stored in the combination is half into C equivalent into V square, V common square. C equivalent, did you calculate C equivalent? C1 plus C2 which is 1600 into 10 to the power minus 12 into 50 the whole square joules, and you get the answer. They didn't ask you for the change in the energy or loss of energy. If they'd asked, then you should put half C1 C2 by C1 plus C2 into V2 minus V1 the whole square. This is a capacitor which is fully charged by a voltage connected to an uncharged capacitor concept. Okay, so that's about the sum. That completes sum number 74 is done. 73 is done. Okay, let's go to sum number 74. I think I missed out sum number 74. I'll just tell you what is sum number 74 talking about. A 900 picofarad capacitor is charged to 100 volts. A 900 picofarad capacitor is charged to 100 volts battery. How much electrostatic energy is stored in it? It's half CV squared. Done. Okay, the capacitor is disconnected from a battery. So you're taking this 900 picofarad capacitor and connecting it to another capacitor which is 900 microfarad, which means we are talking about sharing. They didn't specify it as series, so you can draw it as parallel. What is the electrostatic energy stored by the system? You know that you're going to find C equivalent. Okay, and you have to find the V common potential. The same sum, C1 V1 plus C2 V2. This is uncharged, which means the potential is V is equal to 0, and this has got potential as 100 volts. So you do C1 V1 plus C2 V2, which will become 0, by C1 plus C2, which will give you V common, and then you put you want to find the final energy, which is half into C1 plus C2, which is the equivalent capacitance, into V common the whole square will give you the total electrostatic energy stored in the capacitor. You can try this sum, similar sum. So what is the remainder of okay, so then what is now what is the initial energy? Initial energy for this was half CV square. You find the initial energy for this. Now you found the final energy. You subtract that, that will give you the loss of energy, or you can even put loss of energy's formula direct. What's the remainder? Where is the remainder of the energy? Where has the remainder of the energy gone? Energy is lost during the time in the form of heat and electromagnetic radiation. While sharing, it's getting lost as heat or electromagnetic radiation. Okay, so let's go to next question. This is sum number 75, which I found here. So in this, from the point P, it's connected to this capacitor, from which it's getting split into C2, what is C1 and C3. So C1 and C3 are in parallel, and C2 is in series with that, and C4 is below it, and that's this